Hi, in this tutorial we're gonna go over functions, pros and cons, and the best ways to use them. First thing that we are gonna go over is just explain what functions are. So functions are a group of code that can be executed and they have some input and output. In Blueprints you can create functions in here. You can just click plus and you can name your function. Let's name it test. And that's about it. So on the right you have the details for the functions you have selected. You have your inputs and outputs, and you can have basically multiple of them. So that's kind of the general overview. Now the first pro for functions is that they can be thread safe. General idea of thread safety is that you can run this function on any thread in your CPU, and you can enable that by going on advanced and making it thread safe. Now when you make a function thread safe, it loses a lot of functionality, so you cannot do everything. It's mainly for doing calculations and some simple functionality. So you can't do something like get a reference to, let's say, the camera, and let's type set, maybe projection mode. So if I try to compile this, we're gonna get an error. You also can't print. So if I try to type print, I cannot find it anywhere. So there is some things that you cannot do, but what you can do is, let's say we have a variable, let's say it's a boolean. If I, let's say, use it maybe in a branch, and then use it to calculate some numbers, this should be fine for thread safe functions. So that's a good way to boost your performance, but it can be used on simpler functions. Next pro is that functions can be pure or impure. That basically means that they can have or not have this execution pin. So how functions look like when they're called, so if I type test, this is typically how functions look like. And it is indicated by this blue color that it is a function. And you have your execution pins, and they are for input and output. This is one way to represent a function, but what we can do is click pure on the function, and this makes the function without execution pins. So this means that it needs to be connected by the outputs to actually be executed, which means you can kind of save a little bit of performance if you don't necessarily need to execute something. And this is good for functions where you need to just return some output and do some simple calculation inside of it. So if I go to outputs, click plus, I can basically add as many outputs as I want and then connect it somewhere. So these types of functions that are pure have advantage of being a bit more performant when called once, but since they do not save the values that they generate here, if you call them multiple times, it's gonna have to recalculate these numbers, which sometimes you want, sometimes you don't want. So this is kind of one way to value that. So if I click set in here, let's say we have 3 variables that we want to set with this value. Since we have a pure function and it's connected in 3 separate spots, every time we go inside one of them, what's gonna happen is we go to the first one, it's gonna run this function, get the value. We go to the second one, it runs the function, gets the value. Third one runs the function, gets the value. Now, if this function was impure and we put something like this, we can also clean this up a little bit, just make it a bit more visible. So if we go into the first one, it's going to use this cached value that was calculated. If it goes to the second one, it's going to use the same value again. It's not going to run whatever is inside the function. And same for the third one, and if you have 50 more. So that's kind of a good thing about impure functions. But of course, if you just want to call something once, you would use pure functions. So here are some examples of impure and pure functions. This is a good use because we're just using this one, so we can just call the value. We don't have to spend any performance overhead by calling these execution pins. And how these functions with return values look inside is like this. Basically, when this return node is called, the function is basically completed. So if I do something like this for each loop, and let's say I'm looping over an array of, let's say, 50 values, but let's say I want to stop at the value 25, what I can do is basically say, okay, is this, are we looping over the value that is above 25? Yes, we can just return and we can set custom values here. So we can do something like this. So I'm using Ctrl+C, Ctrl+V to just duplicate the return value. So let's say we do something like that. So every time we hit a return value, that means the execution is stopped and we are exiting the function. So it's not gonna go to all 50 loops if we stop at 25 and return. And this looks the same if it's pure or impure, but the function visually looks like it has execution pins. So if I do pure, but it's just showing you kind of the flow, and you can put a logic for execution here, but it returns this version of it. Okay, the third pro for functions is that they have multiple return values. So we kind of talked about this, but you can have as many return values as you want. Compared to events that cannot have any, this is kind of a good way when you need to actually return something, calculate and return instead of doing some manual work where you update some values. The fourth pro for functions is that they have local variables. So if you look at the local variables tab when we go inside a function, this is where you can add your local variables, and local variables basically means they're only visible inside of the function, not outside of it. So if I add here, type local var, and I try to search it in here, I cannot find it because it's only accessible in this test function. So we can do something like this and then use it in here. So this is good if you want to have some temporary values inside of your function that are only needed in here. And of course, you can set them up the same as normal variables. Okay, so the fifth pro is that they are reusable. So one good thing about function is that they are easily reusable. So you have your functions listed here and you can at any point call as many of them as you want. The biggest difference between them and macros that we're gonna cover is that macros are basically copy-pasted, even if they are grouped in some way. When you compile your blueprint, they're just opened up and pasted basically in your blueprint graph. So that's one good thing, is that you can just basically copy paste them as many times as you want and use them. Next pro is visual clarity. They can be neat and nice to work with because you can just group stuff and it looks way nicer when you clean up your blueprint. So instead of having whatever logic I have in here, just paste it in here and make a mess, you can just basically group stuff using functions. And even do some performance optimizations with the things we talked about, making it pure impure, making it thread safe and stuff like that. Next one is that we have function libraries. So if I right click here and go to blueprints, we can see that we have this blueprint function library. If I create this, let's name it BPL for blueprint function library. And let's type test lib. In here, what we can do is basically, let's name it maybe get value or something. And we can have whatever stuff in here that we want to have. Now what I can do is go into my blueprint, type get value, and you can see here how it references it in our library, and I can get this value and I can call this function in any blueprint, which is really cool with the blueprint libraries. So it doesn't matter where I am. If I have an event graph, I can basically call a value from a function library. And the last pro for function is that it has access modifiers, so you can basically encapsulate stuff nicely in them. So if I click on a function, we can see how we can make it public, protected, or private, depending if you want blueprints referencing this blueprint, have access to the functions in it. So if I make this function private, it's not going to be accessible by anyone directly referencing them. And you can also do protected, so this is for inheritance, so how you want to basically be able to call this function. And this way you can nicely encapsulate stuff inside of a function, so you can manage who and when has access to the functions. So now let's go to cons. So since functions are pretty integral to programming, it's not going to have too many cons, but there are a few of them that you need to keep in mind. So first one is potential for complexity and overabstraction. This means that if you overuse the functions, you can create some complexity and abstract stuff too much. So what can happen is, let's say we have, let's call it call value, maybe we have, let's say, set value. What can happen is you have your test value and then maybe you are calling the call value, and let's make it unpure. And then this call value is maybe calling set value. And now it might be a bit too complicated. You might be abstracting stuff too much, where anyone that needs to debug stuff now needs to go into test, call value, set value, and there is a bunch of layers to your function. So usually you don't want to go too deep when you're creating your functions. You want to use them to group similar things or one specific functionality or one specific use. You want to group it into one thing, but you don't want to over abstract. So you need to keep in mind how much stuff you are calling and what complexity are you making when abstracting stuff into a function. Second con is there is a slight function performance overhead when you're calling them compared to C++ function, which is generally everything for blueprints. So there is a little bit of an overhead. And also when called compared to macros. So if I create an identical function and an identical macro, usually the macro is going to be a little bit more performant. But of course macros are copy-pasted, so there is duplicate code and stuff like that. So functions have a little bit of performance overhead when called, but usually it's not going to be anything to worry about, and unless you're calling a lot of function a lot of times in one tick or something. But even then the overhead will probably be unnoticeable. Third con is there is no async or delays or anything similar inside the functions. So if I go inside the function and try to type timeline, we can see how there is nothing like that in here. You cannot do delay also. The functions are made to be called right away, executed, and kind of forgotten about, so you can't have anything with delays basically. So fourth con is something that I put already in events, and this is generally for blueprints, is that they have limited debug. For functions, you can do stuff that we already covered, but I can cover it again here really quickly, which is you can toggle breakpoints, so when we hit this event, the game will freeze and let you know what we hit. We can also do maybe prints. Let's first disable thread safe. Let's try prints. So you can do maybe print if you want to get some logging for debug, but that's kind of it. There's not much to do with debugging. And the last con is tight coupling, and this is because the functions to be called need to be directly referenced. If I wanted to call this test function, I would have to get direct reference to my third-person character. So if I go in here, let's say I have my third-person character, I'm just gonna put it in the level, and let's go to the level blueprint, right-click, get my character. So if I type test, we can see that we can call the function. So we need to have direct reference, which of course now means that whenever we load the level, we're going to load the character, stuff like that. And if you have some complex web of inheritance, this can get a bit complicated, where maybe you want to call a function, but you have the reference to a parent that doesn't have the function, then you need to cast and stuff like that. So it can get a little bit complicated because you need direct reference. Now, to mitigate this, what you can use is interfaces, and this is going to be the last thing that we cover. And I also created a little example to kind of show you how you can use interfaces where you don't have to have direct reference to an actor or an object, but you can still call and execute functions inside of it. And this can help with this tight coupling. So I created this game mode, and I added a game mode inside of here. And just as a brief overview, if you're not familiar, game modes are basically attached to a level, and they're gonna be running as long as the level exists, and when you change the level, the game mode is changed. That's kind of the general idea, and game mode is made to manage some stuff, but you don't have to go too deep into it. But basically created my own game mode. I'm gonna open it up, and I created an interface that we're also gonna cover. But basically what's happening is if I click play, and I click T on my keyboard, I'm printing a number. And what I'm printing is basically just a score that I just set to 15. I didn't do anything crazy. And what I did is in the player character, when I press T, I get the score, which is a function in an interface from the game mode. Now this game mode is not my specific game mode, it is a general game mode class, so I created a child, and I'm basically just calling a interface on it. Let's now go over what interface is. So if you click right click in your content browser, you can go to blueprints, and then you have blueprint interface. When you click that, you're gonna create a blueprint interface, and it's basically functions but without implementation, so just the setup. So we can see here I created a score, and I set a return value to be score. As you can see, I cannot add anything here, I can just set it up, so no implementation. And then what I did is went into my game mode functions, clicked on class, clicked on implemented interfaces, clicked add, and added my BPI game mode interface. When I add that, I'm gonna get that function or all of the functions in the interface in here, and basically I can use them. If I double click, I would get this without a score. First I added the score. And what's happening is now we can call the parent function of these GM functions, which is game mode base. We can call him, and if you call the function, it should find the function inside of the game mode and execute it. So the general idea, let's kind of visualize this, is let's say this is our game mode functions, and it inherits from just the game mode. So it's a child of the game mode. And let's say we have my character, so I'm gonna just call it C, and I also have an interface, P, oh, that's a bad P, PI, and it has a function called getScore. So if I wanted to, and of course this guy has the score, just for a value, let's do S for score. So if I wanted to access and get the value of this score, what I would have to do is get the reference directly to my game mode functions or GM functions, and then I would have to get the reference of the score. But with blueprint interface, I don't really care about getting this specific child. What I can do is get to my game mode and just say or you get just a generic version of the game mode and just say, hey, do you have this function? And I'm gonna ask it basically for get score, do you have this function? And then he's gonna say yes or no and return me if it has. Since game mode functions is the reference basically that we're getting, but we're getting the generic version of it or the parent version. This guy is gonna be asked, hey, do you have the function, this get score function? And he's gonna say yes and return it us back, even though we have the reference to the parent, not the specific child. So that general idea, I'm not sure how clear that was there, but so basically what's happening in here, now that we have this function and we have everything set up in game mode, is that when we go to the character, this get game mode is a generic function that you can call in any blueprint to get the reference to the game mode. But as you can see, when we hover here, it gets you game mode base object reference. It doesn't get us GM functions. And if I cast from this, cast to GM functions, so if you go this route, if I cast and I set print get score and we get the score and I click play and I click T, we can see we are getting the score. So we are basically doing similar thing that we would be doing with a function, but this way we had to cast a specific game mode and return it, and you can see how there can be difficulties. If let's say you have a character but you have multiple game modes, then you would have to check maybe, okay, is it this game mode, maybe it's not, okay, let's check this type of game mode, is it not, stuff like that. So you would have to do some additional stuff to figure out which game mode you have. Also, casting every time, this costs some performance, so it's not good doing this all the time. So basically our interface helps us make a function that has no implementation and basically can be defined in any blueprint. We can do this get score not even in the game mode, we can do it in any object. So I could do it in our third person character. So if I click out here and type functions or BPI game mode, of course we named it BPI game mode, so we would probably name it a bit more appropriately if we wanted to add it on a character. But if I want, I could add it like this, and now in the interfaces I have this get score and I could implement it in here. The good thing about interfaces is that you can apply it to any blueprint and then you can use it to identify the blueprint, or you can use it to add some functionality to the blueprint that is generic. So now if let's say I have a reference to some other character, let's say third person character functions. So I have the reference to some other character. What I could do is basically type get score and I can call the interface node, and if he implements it, we can do the same thing. So now to just kind of show you more practically how to implement something, let's add the set score. So let's say when we click R, so let's do R, okay, it's here. So let's say when we click R, we want to set score to whatever value we want in here. So let's now go to the BPI game mode, let's click add, let's type set score, and for the inputs let's put it on integer and let's type score, or maybe we can do like new score or something. And now when we go to GM functions, we are automatically gonna get this new value or this new function. Now when we double click it, we can see that it creates an event, and if I wanted to make it a function, what you can do is add an output, then again add the score in here, so it's going to be like a function, and then you can basically delete the output and you can have it as a function. But for now we're going to use it as an event. So now let's take the score and let's set it to the new score, and that should be it. Now let's go back to our character and let's type in here set score, and you can see this is kind of a message. So it says this does nothing if the target does not implement the required interface. Let's connect it here and let's say new score is 25, and that should be it. So now let's click play. I'm gonna click T first, so we have 15. Now I'm gonna click R and click T again, and now we have 25. So it's pretty easy to set up interfaces. For me, they were confusing at the beginning just because calling them was kind of weird. I didn't understand properly the inheritance way of calling them and stuff like that. When I figured it out, it was pretty easy and straightforward to use them. And this way you can avoid tight coupling and you don't have to create deep inheritances. So if you remember from some previous videos that I talked about, where you have a bunch of nested children, where you can create like a mess with inheritance. So with interfaces, you can basically have similar implementations, but not the same for basically each character. So they are pretty useful in that way. So this is about it for functions, and let me know if you have any questions or anything else.